Okay, so we are going to go over the atomic theory review quiz that you took. And I'm going to go through each question and do the headwork of how you should be thinking about it. So the first one says, which subatomic particle is negatively charged? Well, if you didn't know that the answer was the electron, then I would direct you toward table O, and you wouldn't even have to guess. Because if you go to table O, you will see that all of these are listed there, and the charges are listed as well, because it's the bottom number. What is the mass of a carbon atom that contains 6 protons, 8 neutrons, and 6 electrons? Well, this comes from memorization. You have to remember that the mass number is equal to the protons plus the neutrons. For purposes of this class, electrons have no mass. So if I had 6 protons, 8 neutrons, that would be a total of 14. An atom in the ground state has a stable valence electron configuration. This atom could be an atom of what? Well, as soon as they say stable valence electron configuration, you want something with 8 valence electrons, because that's what every element is trying to do. They're either trying to give up electrons or gain electrons until they get to 8. So all you would have to do is look up the electron configurations on the periodic table, and you would see that it was neon. Which electron configuration represents an atom in the excited state? Excited state means that an electron has jumped from a lower level to a higher level, leaving a lower level partially filled, which means that you're not going to find the electron configuration on the periodic table. So the easiest way to do this is add up the number of electrons. So this one has 9. This one has 10. This one has 11. And the last one has 20. So remember, 20 electrons, that also equals the number of protons. So if you were to look up this, number 9, this would be fluorine, the first one. Well, that's what appears on the periodic table. If we go to 10, that's neon. Well, this configuration does not match that of neons, because on the table it says 2,8. So that is more than likely our answer. The next one is 11, which is sodium. If you look at sodium, it says 281 right off the table. And the last one is calcium, and that is the one that's on the table for calcium. Which information is necessary to determine the atomic mass of the element chlorine? We went over this when we did our review, and actually this is the same question that was in our review packet. You need the mass and the abundance for each of the naturally occurring isotopes. In fact, I gave you a hint because it was listed right here at the top of the table. So the answer would have been C. Atomic mass and relative abundance, which means percent, of each naturally occurring isotope of chlorine. Next question got a lot of kids because they did not answer it in terms of the number of subatomic particles. Subatomic particles can only refer to protons, neutrons, or electrons. So one similarity is that they have the same number of protons. One difference is a different number of neutrons. Now, on this quiz, I gave people half credit if they got the similarity right and the difference wrong. However, if it was the regents, they wouldn't give you any credit at all. Okay, moving on to the next question. In the space provided, calculate the atomic mass of sulfur. Remember, we said it was mass times percent plus mass times percent plus mass times percent for all 4 isotopes and divide by 100, or you have to move the decimal. So I'm going to show you both ways. If I move, so first let me do the divided by 100 over here. So I would have 31.97 times 94.93 plus, I'm just going to do it like this, 32.97 times 0.76 plus 33.97 times 4.29 plus 35.97 times 0.02. And then all of that divided by 100. Now, the other thing we could do is we could move the decimal point 2 places to the left, and then we would just have 31.97 times 0.9493 plus 32.97 times, got to add zeros as placeholders, 0.0076 plus 33.97 times 0.0429 plus 35.97 times there's got to be 3.0002. And then we don't divide by 100. Either way, I believe the answer came out to be 32.06, somewhere around there. All right, next question. An electron in a sodium atom moves from the third shell, I'm blocking something, to the fourth shell, I believe it said. What's happening in terms of energy? Well, when you go from low to high, you always absorb energy, and we talked about that in class. When you go from high to low, you release energy. Just think of it as you need energy to climb the stairs, all right? Okay, first question. Which electron configuration represents an excited state for potassium? And I went over this in class. I said there's an easy way to remember how to do this. Potassium is K. It has 19 electrons. So the first thing that I want to do is count up all of the electrons. Because remember, the number of electrons stays the same. They just move from one shell to another. So choice A has 18 electrons. Well, we can get rid of that one. Choice B has 19. We're going to leave that one. C has 19. And D has 20. We're going to get rid of that one. So I have two choices left. I need the excited state. How much do you want to bet one of those is the ground state? Well, sure as enough. If you look at the periodic table, if you look at potassium, 2881 is the ground state configuration of potassium. Why? Because we can find it on the periodic table, which means that B is the winner. Winner, winner, chicken dinner. There you go. All right. Bright line spectra. Remember that in order for the elements to appear in the mixture, all of the lines have to appear in the exact same spot. So if I look at D, all of my lines for D match up. If I look at E, all of my lines for E match up. Right away, I can see that G doesn't match up. That line is not there. Neither is the next one. So the only two that appear in the mixture is A, E, and D. All right, number 11. Which type of matter is composed of two or more elements that are chemically combined in fixed proportions? Guys, classic textbook definition of a compound. Technically, I'd like it to say of two or more different elements, but it is a compound. Particles arranged in a crystal structure. So I tried to give you an example of that. Anytime you see particles that are close together like this, it means it's a solid. Anytime you see particles a little bit further apart, okay, that means it's a liquid. And anytime they're completely spread out in the space that you're given, that means it's a gas. So this little hint that I drew on the quiz was to help you identify a solid. And of course, the only one that was a solid was D, silver, because it had the S after it. Matter can be classified as a substance, meaning pure substance, element or compound, or a mixture of substances, homogeneous or heterogeneous. And in the last one, each diagram to the right represents the nucleus of a different atom. Which diagrams represent nuclei of the same element? Well, what identifies an element? Its atomic number. And the atomic number is the number of protons. So D had 1 proton, E had 1 proton, and Q had 1 proton. So those are all the same element. They are isotopes of one another because they have the same atomic number, meaning same number of protons, but a different mass number, different number of neutrons. So the answer was B, D, E, and Q. And that wraps it up for our atomic theory review quiz. Okay, see you on Monday. It'll be an A day.